Welcome to this lecture 24, this on automatic generation control. I am sure all of you are aware that frequency is as important as voltage, if not more. We have been seeing in last many lectures how voltage is to be controlled. Now, we also need the frequency control. Now, that is a different matter, that frequency has to be controlled in a very narrow band. Well, voltage indeed was also in narrow band, plus minus 5%. Here it is plus minus 0.5 hertz. PD and QD, as I told you, these are our load demands. D is demand, P is the real load and Q is the reactive load. Now, unfortunately or fortunately, they are never steady. They keep on changing all the time throughout 24 hours, 7 days, 30 days in a month and 12 months. Unfortunately, the change is also random. You can predict. Load forecasting is a very important topic, but nobody can really forecast with complete certainty, and that is why it is a random variable. And this change is also unfortunately not in one direction. It can be in plus minus any direction with time. It can go up, it can go down. At what time you will switch on your fan? Nobody knows. At what time you will switch off your fan? Nobody knows. How much you will operate that mixie for preparing chutney or anything, even the housewife doesn't know. Whenever she likes, oh, so it seems to be okay, and switches her off. So, there is no fixed duration for which you will be running a particular device. Steam input to turbo generators or water input to the hydro generators must therefore be continuously regulated to match the active power demand. Since PD and QD, they keep on varying, correspondingly your steam input or water input should also keep on varying up and down, is also up and down. So, there is a constant match is going on between them to keep track of each other, right, continuously, constant. Failing which, suppose you do not do it, suppose you say I do not care, then what will happen? Then machine speed will vary. Once the frequency varies, the speed will vary. Once the speed will vary, the performance will vary, because motors are supposed to operate in many applications, constant speed applications. For example, it is a flour mill. Now, if that motor speed changes, the atta will have a different variety in that 5 minutes, if the speed keeps on changing. Or even that paper machine, paper factory, the Times of India, each page will be of different width. How do you like it? Each book of each page, if it is of different width, different length, different thickness, the book will look awful. So, speed has to be constant, but if frequency is varying, naturally speed is linked with the frequency. F is equal to Pn by 120. So, if P being constant, number of poles, 120 being constant because the number, so there is a direct relationship between frequency and speed. If there is a delta F, corresponding delta N is bound to be there, whether we like it or not. Change in frequency which may be highly undesirable. Think of the clocks, the electric clocks. Now, if frequency changes, the time will also change. Now, that will play havoc. How can you just keep on changing the time with speed? So, it has to be absolutely constant frequency operation, That is all synchronous machine is all about. It operates at constant speed because frequency remains constant. If there is a change in frequency, there is a change in speed, again and again I am repeating, of the consumer's plant, affecting production processes. I have already explained you how different changes will affect different products, be it paper, be it clock, be it atta, flour mill, anything. So frequency constant is more important than voltage constant, because voltage constant we have a certain voltage stabilizer, a UPS, but frequency stabilizer is very rarely used. We have frequency stabilizer. So that power station works satisfactorily, in parallel the various motors operating on the system run at the desired speed, at the rated speed for which it is designed. So designed speed, rated speed, desired speed, required speed, whichever word you want to use. The idea is there is a fixed speed at which a particular motor, particular device is supposed to work. Correct time is this is what I was telling you few minutes back. Correct time is obtained from synchronous clocks in the system. There will be no correct time available, and not only that, it will then have an error, and this error will be cumulative. See, as there is someone says, even the clock which is stopped shows correct time at least twice a day, in a day, twice in 24 hours, but the clock which is running behind, it is never showing correct time. So even the clock which is stopped is better than the clock which is not showing correct time, because that clock will at least show twice the correct time. What about entertainment devices? TV, VCR, home theater, cinema, all this, if the voltage changes, if you see a movie in a village, you will find that every reel there is a different, because the power is coming of different quality. You can see even in your hostel, when you get power from standby generator, it is of different quality. Then you get power from BSNL or DESU or DVB, whatever is this name. Maximum permissible change, I have already talked about it in the beginning of the class, is plus minus 0.5 hertz. But in India, we have a special country, so we have special requirement, we have plus minus 2.5 hertz. That means it can go from 47.5 to 52.5 hertz. But in the world standard, it is plus minus 0.5 hertz. If it is crossing beyond 49.5 or 50.5 or 59.5 and 60.5 in United States, immediately AGC will come into play. AGC is automatic generation control. Unfortunately, we do not have any AGC in this country so far. Also, the excitation of generators must be continuously regulated to match QD. We have been talking about PD so far, real demand, but the reactive demand, the reactive generation we have to change. That means we have to change excitation of generators. We want to keep the QD constant. Otherwise, the voltages at various system buses may go beyond the prescribed. This of course problem we have studied very well in past, in earlier lectures. If you do not do that, the voltage will go beyond limit, either lower limit or upper limit. Now, here is a schematic diagram of load frequency and excitation voltage regulators of a turbo generator. From here the steam is coming. How steam is produced? By burning coal, water getting heated up, boiler, then steam is passing through turbine. The fuel can be coal, fuel can be natural gas, fuel can be nuclear fuel, it can be uranium, it can be thorium, it can be plutonium, it can be anything, it can be multi-fuel. As I told you, now cars and buses are run on multi-fuel. Similarly, here also there can be multiple fuels. Once the steam at a proper temperature and proper pressure enters the turbine, which is running at some speed and connected to generator, the power is generated. And you take a sample from this power P plus JQ, which is fed to the grid. All those transformers, circuit breakers, all things are there. It is not shown in the figure, but that you know. Sample this frequency, compare it with reference frequency. You must have done control system in your earlier lectures. So, you have to compare this whatever frequency comes. Let us say it is 48 hertz. The reference frequency is 50 hertz. So, there is a frequency sensor and comparator is there in this block. It will then control the steam valve controller, because if frequency is low, you have to increase the steam input. If frequency is high, you have to decrease the steam input, and likewise with hydro, you have to open the gate or close the gate accordingly depending on what is the frequency. If frequency is below 50 hertz, gate opening will go up, unless it is already it is full, then you can't do anything. But if it is not full, assuming that there is a scope for control, then we will put it up. If it is frequency is higher, which also happens, then we have to put the water down. This is a steam valve controller, and then the signal goes here. This is called comparator in control system language. And then we control the steam, is a controller, and turbine will then operate in such a way that you generate power of correct frequency. Till that time, this feedback goes on, right. Simultaneously, there is a voltage control loop. You can't separate them. P and Q, this is choli daman ka saath, you know, they are always in hand. You can't separate them out. You may analyze them separately, you may control them separately, okay, you may use them separately, but they are together whether you like it or not. So, similarly, you take a voltage sample and there is a voltage sensor and comparator. This is again a V reference. This is like F reference, this is a V reference, and if there is a mismatch more than certain epsilon, what is epsilon here? Plus minus 5%. What was epsilon there? Plus minus 0.5 hertz. So, this is a epsilon frequency, this is epsilon voltage. Allowable permissible variation, right. Then again a signal goes, excitation controller, it goes, then this is a field winding, the excitation is controlled, and then you get a proper hold. Till this happens, we do that, okay. Why these two loops? One is a voltage control loop, another is frequency control loop, don't interfere with each other. Why? You can ask me why these two guys, when they are together, don't interfere, because their time constants are entirely different. This is a faster control, this is a slower control. So, they don't interfere with each other. I hope this is now fully clear. You can always see the more explanation in the book, any book, whichever you want. The Algert book also gives AGC very well, our book also gives AGC, and then there are so many books. Now, this is a turbine speed governing system. It is a very important system, control in power system. This is a speed changer, right. If you lower it, you want to lower the speed, it goes up. If you want to raise, it comes down. This governor you must be knowing for ages, fly ball. And if it collapses, then piston moves in one direction. If it expands, piston moves in another direction. And what will happen? The amount of steam input will get controlled. That is all you wanted. Now, direction of positive movement is downwards. L1, L2, L3, L4, these are the lengths of mechanism, the linkages. This is a rigid link pivoted at B. This is another rigid link pivoted at D. You just consider here pilot valve. This is the input for the high pressure oil. Now, if D goes down, this comes down and this gets open, and the oil will enter like this and pushes this main piston upwards. That means you are closing this steam valve. So, steam input will be restricted, minimized, decreased, lowered. Opposite happens if this D goes up, then this entry is not available. The oil will enter from here and will push piston down. That means you will open the steam valve. That is all. For that, this is a complicated hydraulic amplifier is here, speed control mechanism. This is a main piston, this is a pilot valve, this is the high pressure oil which operates this whole governing system. So, if you are asked that draw the speed turbine speed governing system and explain its function, this is what you have to explain depending on number of marks. If it is 2 marks, 4 lines. If it is 5 marks, 10 lines. If it is 10 marks, then 20 lines as given in the book. In modern large interconnected systems, see, as I told you, in spite of distributed power systems and dispersed power systems, the fact remains the integrated power system is going to continue. They are not going to throw away thousands of kilometers of transmission lines they have built in the country with lot of effort. They are not going to throw them. They are not going to throw any conventional power system, power stations, just because you have a solar, you have a wind, you have hydrogen, you have a tidal, you have a geothermal, you have MHD. They are separate in axis. The main dish will continue to be roti, chawal and chapati, sabji, dal. You may go on adding small, some snacks, some sweet, some salad, soup, etc. So, they will be like that only, distributed and dispersed power system. So, we will continue to have, whether we like it or not, this modern large interconnected system in operation for foreseeable future, that is 2050. Manual regulation is not feasible in such a big system. How can you regulate manually? And therefore, automatic generation and voltage regulation equipment is installed on each generator. And let me tell you, generators are not many, they are only 10% of the total number of buses. Figure 1, which you have already seen, gives the schematic diagram of load frequency and excitation voltage regulators of a turbo generator. The controllers are set for a particular operating condition. Initially you have to set. When you start from your home, you set a car to a particular speed. Then you manipulate it, control it, depending on if some vehicle comes in front of you or road is clear. You are driving at midnight to go to Indira Gandhi Airport, then you can go faster. 20 minutes you will be there. But if it is a morning 9 a.m. or evening 5 p.m. rush hour, you have to go in slow mode. So, particular operating condition, and they take care of small changes in load demand without frequency and voltage exceeding the prescribed limits, those regulators. With the passage of time, as the change in load demand becomes large, right? If its fever is around 99, nobody goes to doctor. You may take some paracetamol, crocin, or in olden days just tea with the tulsi leaves, it will set you right. But if it is 102, 103, then because of dengue fever, fear, etc., you go and immediately get your all blood test done. So, if load demand changes are large, then controllers must be reset. How you reset? Either manually or automatically, depending on what mechanism you have in your system. Okay. You remember those olden days TV when you used to control the voltage by actually getting up, taking a trouble and going up to the TV set, and now nobody wants to get up. If they want, they can have a remote for wearing suit also. Don't know, no physical labor they want to do. So, for every damn thing there is a remote now sitting, and that is why there are problems, health problems. So, the controllers must be reset either manually or automatically. These are the only two ways. It has been shown that at least 100 times we must have repeated that real power depends on delta and it does not depend on voltage appreciably, to be exact. After a lot of approximations you can show, you can remove delta also from delta q equation, and you cannot remove V anyway from P equation, that EV by x into sin delta, but those E and V's are constant supposedly. But voltage is proportional to excitation and Q is not proportional to delta, this we have shown, if you recall that. Okay. Delta Q is equal to del VR upon x into delta V, where delta V is delta Vs minus Vs minus VR. Delta delta caused by momentary change in generator speed. Therefore, load frequency and excitation voltage controls are non-interactive, because they are not dependent on each other. When voltage loop is operating, the angle or speed loop may not operate. They are non-interactive. This word is very important. For small changes and can be modeled and analyzed independently. That is the approximations. Excitation voltage control is fast acting. I told you earlier that loop is fast acting. The time constant is small. Whereas in that frequency loop the time constant is large, so it takes longer time. What is the time constant? Reaching 63.2% or something like that. It takes more time. Major time constant is generator field, which is larger, and hence power frequency control is slow acting, with major time constant is turbine and generator model moment of inertia. The book gives all various ideas of different time constants that you can read. Thus the transients in excitation voltage control vanish much faster because it is a quick acting and do not affect the dynamics of. This is very good thing that God has done, that these two loops are non-interactive. Otherwise there would have been a further complications. You try to correct frequency and voltage get corrected. You try to, when it is not required to be corrected. You try to get voltage control and frequency get corrected. Corrected means disturbed. But luckily they live together, but peacefully, no interaction. Like nowadays in hostel our students live 3, 2 or whatever number without any interaction. Undesired interaction. The desirable interaction should be there. So these voltage control vanish much faster and do not affect the dynamics of PF control. So change in load demand, slow varying changes in mean demand, fast random variations around the mean. These two things are entirely different. The mean may vary very slowly, but around mean variations can be fast. Regulators must be designed to be insensitive to fast random changes. Should not act just it is 99 or 98.6, you should not go and take paracetamol. Allow it some time so that it may go off its own. Like swings, power swings in protection, you must have read. Don't just get your relays operated unnecessarily. It may be just a passing, swing, it will go. All pain here is not a heart attack. You should not rush to the bypass surgery. It may be just a gastric pain or just like that. So regulators must be designed to be insensitive to fast random changes, because we don't intend to take note of them. They will come and go. Otherwise the system will be prone to hunting. Hunting is a very important topic in synchronous machine, and to avoid that we have a damper winding and second order equations we have written, and we can analyze hunting, resulting in excessive wear and tear of rotating machines and control equipment. Like using brake should be used very sparingly. It gives you jerk. The fellow who is sitting back, if he is not careful, he may hit the top if the car is small, or he may have a back pain. Load frequency control, now we will study in detail for a single area case. What is single area? Single area means Delhi, state of Delhi. We don't consider Haryana, we don't consider Punjab, we don't consider UP, we don't consider Uttaranchal, neighboring states. So only Delhi. Just your house, just your room, not the whole hostel. So power output of the generators of a closely knit electric area so as to maintain the scheduled frequency. At least you have to keep your room clean, then only you can talk of hostel being clean. Right. So if you maintain your frequency in your area, naturally it will help the larger system also, because this is called component to subsystem to system approach. This in system theory is another branch of electrical engineering, in fact all engineering, because there is a system everywhere except India. India there is no system. So component to subsystem to system approach. So you have to take care of components, then subsystem, then system. As it is known that if you take care of penny, pound will take care of itself. If you are not spending any penny, where is the question of spending pound? All the generators in such an area constitute a coherent group. What is the meaning of coherence? Coherency is a very important topic in electrical engineering. Yes, it's a larger meaning is not just same frequency. For example, two of you move together. You go and take tea together, you go and take breakfast together, you go and take lunch together, you live together, you want to die together, that type of thing. And that is called coherency, coherent group. Do sharir ek pran, something like that. Always moving together. Similarly, these all generators swing together. If you plot their swing curves, I am sure all of you know what is swing curves. Delta versus time. So another will have similar. So we can say they are swinging together. So if you study the stability of one, automatically where is the Ram? Is where is Sham is. So if you know about Sham, Ram is normally found there only. That is a coherent group. So all the generators in such an area constitute a coherent group. Delhi, Indraprasth powerhouse, Badarpur powerhouse. Naturally, whatever happens to Badarpur will happen to Indraprasth because they are all interconnected, and a small well knit coherent group, that is called DESU or DVB or BSNL system or Tata Power, whatever is the name. So that all the generators speed up and slow down together. They swim or sink together, maintaining their relative power angles. So delta 1 2 will be 0, delta 1 minus delta 2, because the values are same. Such an area is defined as a coherent area. So if you are asked in the exam, define a coherent area. For example, given electricity board, E board is not like e-governance or something, electronic board. It is electricity board here. For a change, E stands for electricity. Consider a single turbo generator system supplying an isolated load. With distributed system and dispersed system coming back, they are not replacing the interconnected. I told you some time back, but they are very much there now. Why? At every village, every far off place, Kutch, Leh, you cannot take the grid. We are a poor country. Where is the money to build? Even in today's paper, it is saying there is an item that Agartala to Dhaka bus is a failure because there are no passengers. So such a link will be a failure where you need only 2 megawatt, and that 2 megawatt is coming from Delhi to Leh. It is better to generate that 2 megawatt in Leh itself, and there where the importance of distributed power system and dispersed power system there, even if the generation cost is bit higher. Let us argue with those people who are against non-conventional energy sources. You explain them, how about the cost of transporting or transmitting or taking power from Delhi or even nearest, let us say Punjab to Leh, let us say Pathankot or Jammu, wherever your power station is. Going to Leh itself is about 300-400 kilometers just for 2 megawatt, because requirement is not much. Not many people stay there. So consider a single turbo generator system supplying an isolated load, like Leh, Kutch, they are all isolated loads. I have already shown that second figure, turbine speed governing system. Now we were talking about this fly ball speed governor. I have shown you that picture. It is the heart of the system. It senses the change in speed. Speed and frequency are same thing. As I told you, they are only differentiated by a constant. P n by 120 is f. As n goes up, the fly balls move outwards. And point B on linkage mechanism moves downwards. Reverse happens when the speed decreases, and ultimately naturally it will operate those valves, pilot valve, and the amount of oil will be controlled, amount of oil will in turn control the opening of steam valve. So, it will again control the input of steam to the turbine. Either it will increase or it will decrease depending on whether you want more generation power or less generation power. What is hydraulic amplifier? Pilot valve and main piston arrangement. Let P, pilot valve movement, low P means low real power, high power level piston valve movement to open and close the steam. So, the piston valve needs high power, this pilot valve needs low power. So, low power can operate that. So, you are changing this low power piston valve movement into high power level piston main piston valve movement, pilot to piston. What will do? It will movement will open and close the steam valve. I have explained it several times. So, now it should be clear to everybody. Linkage mechanism. ABC I have already talked about it, and CD there were rigid links. It provides and B pivoted at B pivoted at D is a shortcut language I have used because I already explained you in the figure. It provides a movement to the control valve which is proportional to change in speed. Change in speed will trigger this. If there is no change, this fellow will sit quiet. It will have a coffee break, tea break, nothing. No piston valve movement, no main valve movement. What for? You are getting your constant speed is operating, constant power is being generated, no frequency is beautiful 50 hertz, the voltage is excellent 220 volts or 11 kV whatever, and nothing, no AGC will operate, no voltage control mechanism will operate. What for? If you are fine, 80/120 blood pressure, temperature 98.4 degree Fahrenheit, pulse is 80, why should you go to sick bay? You should have no stop there, straight away come to institute. It provides a movement to the control valve proportional to change in speed, also gives a feedback from the steam valve movement. Speed changer. It provides a steady state power output setting for the turbine. If speed changes goes down, opens the upper pilot valve, more steam will come. This also I already explained. Speed changer, and more steady power output will be obtained once the speed valve opens. Reverse will happen for upward movement of the speed changer. The speed valve will get closed, less steam will go, and the less steady power output will be there, because the requirement has changed. It is not required, so why should we generate more power? It is not only that it will operate when frequency changes, even if your power requirement goes down, naturally you have to bring down the steam input. So, do not think this mechanism will only operate if there is a change in frequency or change in speed. Even if change in power requirement changes, you have to generate less power. Why should you generate more power? Model of the speed governing system. You must have done solved this block diagram, you must have drawn several times in doing your control system course. F0 is a system frequency, PZ0 is generator output, which is here, and turbine output. Let us assume they are equal. If you assume that losses are not there, this is a governor block diagram, this is a turbine block diagram, this is a power system block diagram. All these diagrams are given in detail in the book. So, since there is no time, we have only one more lecture. So, kindly go through this in detail in the book. Tomorrow we will solve two problems also, that will be a tutorial type thing. Maybe we will solve here itself, whether they do this or not, it hardly matters. This 1 by R is a controller, regulation constant. This is a BD. BD means block diagram model of LFC. LFC means load frequency control, isolated power system, just one power system. This is a change in frequency. This is a feedback. So, this gives a correction. It compares with the scheduled frequency. If there is a change in them, there is an error, then it goes to governor. If there is nothing, fine, no control is required. Let us do steady state analysis. Two important incremental inputs to the LFC problem is change in speed changer setting and change in load. These are the only two inputs. Consider that speed changer is fixed. So, we get rid of one input. The only input is, and such an operation is called free governor operation. This is asked in many interviews. What is a free governor operation? All IS exam, all engineering services exam, all NTPC, power grid or anywhere. It only means your fixed setting of speed changer, and that is called free governor operation. Governor is free, it is not controlled. So, find out the change in the frequency for change in sudden change in power demand. Sudden change means step in. Step means 1 by S is the Laplace transform. Sudden change, and this equation is very important. It relates the change required in delta frequency because of change in demand, where R is a speed regulation, B is a power system constant. B can be ignored, as we will see in our next slide. R is so adjusted in such a way that delta F is small, of the order of 5% from no load to full load, change in frequency. Therefore, linear incremental relation can be applied. Now, this figure is very important. Study this figure carefully. Y axis is frequency percentage, starts with 100, 103, 105, stops at 105 because we do not allow more than 5% variation. What is x axis? Percentage load, 60%, 100%. You may require just 60% of the load. It is a night time, all loads are switched off. The month of November, neither heater is there, nor fan is there, no cooler, no AC, no even fridge. So, the load drops. So, you may operate at 60% of the load, yet you need a frequency same. 60% load does not mean you can reduce your frequency. The frequency is still required is 50 hertz. So, load can be 100%, the frequency is still required to be plus minus within 5% range. And droop, this is a droop characteristic. Why droop? The load goes up, frequency drops. Okay? Though it is linear, but it is a droop characteristic, and this is the slope is given by 1 upon R. B is very small, you can ignore. It will become minus R, because if B goes 1 by R, R goes up. Speed changer set to give scheduled frequency at 100% load and 60% load, and that is why delta F then will become minus R delta PD, and this R is a speed governor regulation. So, with this we will stop today. Tomorrow we will solve a couple of problems, then we will go further, and the AGC topic goes on. It's not just one area. We have just considered one area. Then there can be two areas. Then both areas linked with a tie line like this, and there is a tie line, it's interconnected. Now you have to have AGC of this two area control. There can be third area. This can be thermal, it can be thermal hydro, nuclear. It gets complicated, involved. Deadband control. You have to consider deadband also. What is deadband? Any idea? There is certain time for which controller doesn't operate. It takes time. Like certain effort is required to continue to run the machine at no load. There is no output, but still input is there, because you have to supply losses. Then there is a generator rate constraint, JRC. It takes time to increase the generation. It is not no time. So rate of generation increase, which is 20% in hydro, I told you in the first chapter. Thermal, it takes more time, it is slow. So with this, ladies and gentlemen, we will stop today. Any questions you have for today's lecture?
So, AGC is reset when voltage demand is higher.
What is voltage demand?
Means I didn't get this concept.
Sir, when that is changing too much, then it resets. Otherwise, it takes care of the load.
That's right.
That was the
See, the changes are small, then you don't have to reset it. It will take care of itself. But if changes are violent, large, then whole setting has to be rechanged. Okay? Any other thing?